Alright, in this video we're going to talk about adding and subtracting rational expressions, which is a lot like adding and subtracting fractions. And I did a video a while back about adding and subtracting fractions, so if you haven't checked that one out, you might want to go see that, because we're using the same basic principles here to add and subtract the rational expressions as we did when we were adding and subtracting fractions. Right? And that basic principle is, when you add or subtract fractions, you need to first find a common denominator for those fractions, and then use that rule of fractions that says if I have a over c plus or minus b over c, I add or subtract the numerators and keep that denominator the same. So that equals a plus or minus b over c. Right? It's the same rule whether it's addition or subtraction, but you can only add those fractions if they have that same denominator. Right? And when they do, you keep that denominator the same and you just add or subtract the numerators to get your answer. All right, so we're going to do a couple examples here of adding rational expressions. Well, the first one is just adding a couple fractions just to remind us how that works, and then we'll apply that to adding the rational expressions where we have these algebraic things kind of mixed into it. All right, so the first one here, I have 1/2 plus 2/3. All right, so obviously those two do not have a common denominator, right? They have a 2 and a 3, which are not the same number. And so I need to make them into common denominators. And normally when I do that, or when I look for a common denominator, I factor my denominators. But here, I can't really factor the 2 and I can't factor the 3. Right? 2 and 3 are both prime numbers. The only things that multiply to equal 2 are 1 times 2. And same for 3, it's just 1 times 3. Right? So I can't really factor those. And so since I can't factor them, my common denominator is just going to be the two of these multiplied together. Right? So that's what happens when your denominators can't be factored. If they don't share a common factor, your common denominator is just the product of all of your denominators multiplied together. Right? So my common denominator in this case is going to be 2 times 3, which equals 6. Right? So that's going to be the common denominator. So I need to change my two fractions to that common denominator. Right? To change the 1/2, remember what I do is, to change the 2 to a 6, I have to multiply it by 3. But I cannot do that unless I also multiply the numerator of that fraction times 3. Right? Because remember, 3 over 3 equals 1. So if I multiply 1/2 times 3 over 3, I'm multiplying it by 1, which doesn't change the value of the fraction. It's basically just unsimplifying that fraction. Right? And then the same idea for that 2/3. Right? I have a 2/3 here. In order to change that to a denominator of 6, I have to multiply the 3 times 2. Right? Basically multiplying each one by the denominator of the other fraction. Right? This fraction here, the 1/2, I multiply the top and bottom by the denominator of 3. The fraction over here, the 2/3, I multiply the top and bottom by the denominator of 2 from that other fraction. Right? And again, I multiply by the 2 on top and bottom because 2 over 2 equals 1, and I'm allowed to multiply by 1 without changing the value, just kind of unsimplifying the fraction. Right? So when I do that multiplication there, right, 1 times 3 is 3, 2 times 3 is 6, so I get 3/6 plus 2 times 2, which is 4, 3 times 2, which is 6. So I get 3/6 plus 4/6, and then when I add, now that they have the common denominator, I just add across the numerator. 3 plus 4 is 7, so I get 7/6. Right? So 1/2 plus 2/3 equals 7/6. All right, so that's how we add fractions when they don't have a common denominator. And if those denominators do not have a common factor, basically I just multiply each fraction by the opposite denominator. All right, so let's see how that applies to rational expressions where I have algebraic stuff going on here. So I have 3 over x minus 1 plus x over x plus 2. All right, so obviously I don't have a common denominator here. Right? One of them is an x minus 1, one of them is an x plus 2. Those are two different things. And so I cannot just add them together as they are. I need to find a common denominator. So what my common denominator is going to be, well, kind of like what I had up here with the 2 and the 3, where I couldn't really factor these. The x minus 1 I cannot factor, and the x plus 2 I also cannot factor. Right? They don't have any common factors. Right? The x and the minus 1 don't have a common factor. The x and the plus 2 don't have a common factor. There's nothing I can do there to factor those. They're about as simple as they can get. Which means my common denominator is going to be just those two factors multiplied together. X minus 1 times x plus 2. Right? Just like up here, the common denominator was the 2 multiplied by the 3. If these two denominators do not have anything in common, your common denominator is just multiplying them together. All right, so that's what my common denominator is going to be. And so for my first fraction, the 3 over x minus 1, I need to multiply that by the x plus 2, right? That's that factor that's missing, right? So I need to multiply that by x plus 2 over x plus 2. Right? Again, just like up here when I multiply by 3 over 3, which is 1, I can multiply by 1 because it doesn't change the value of the fraction. Here, if I multiply by x plus 2 over x plus 2, still I'm just multiplying by 1. I just write that 1 in such a way that when I multiply it, I create that common denominator for my fractions. Right? And then the next one, plus x over x plus 2. This one has that factor of x plus 2, but it doesn't have the factor of x minus 1. Right, so I'm taking the denominator from the other fraction, and I'm multiplying the top and the bottom of that second fraction by the x minus 1 from the denominator of my first fraction. Right, so if you're ever in doubt when you have to add rational expressions like this or subtract, it's the same rules for subtraction. If you're ever not sure about what to do, you can always just go ahead and, well, whatever this denominator is, let me multiply the top and bottom of this fraction by the x minus 1. Let me take the top and bottom of this fraction and multiply it by the x plus 2. Right? If you just multiply the other fraction by the other fraction's denominator, you will create a common denominator. All right, so we've got this, and now we need to basically simplify all this stuff. All right, so I have 3 times x plus 2. So if I distribute that 3 there, I'm going to get 3x plus 6. All right, and then here I have an x times an x minus 1. So if I distribute that x into that parentheses, I'm going to get an x squared and then a minus x over the x minus 1, x plus 2. All right, now when we're doing a problem like this, we do want to multiply out the stuff that's in the numerator so that we can combine like terms and see if there's any way we can simplify this. But the stuff in the denominator we do not want to multiply out. We want to leave that in the factored form of the x minus 1 times x plus 2. Right, and I'll explain a little bit more about why we do that when we get towards the end of this one. All right, so my numerator now, I have an x squared, I have a 3x and a minus x, so that's going to be a plus 2x, and then I have a plus 6. And then I have an x minus 1 times an x plus 2 in the denominator. All right, so that's what I get when I multiply out my numerator. I add the two fractions together. Remember, once these two have a common denominator, I just add straight across the numerator, which is why I'm able to just put all those together into one single fraction there. And then I can combine like terms. And now what I want to do is see if I can simplify this some more. All right, I have an x squared plus 2x plus 6. Can I factor that? And if I can factor that, will any of those factors cancel out with the x minus 1 or the x plus 2 that's in the denominator? That's why we don't want to multiply this stuff together down here, because if I can factor that numerator, and let's say that equals x plus 2 times x plus 3, well then I want to have this x plus 2 here so that I can cancel those out and simplify my answer. Right? That's why we don't multiply this out. All right, so can we factor x squared plus 2x plus 6? I would need two numbers that multiply to 6 and add up to 2, and those numbers just don't exist. Right? The numbers that multiply to 6 are 6 times 1 and 2 times 3. Neither one of those are going to add up to a positive 2. And so since I cannot factor that numerator, that means I cannot simplify this any further, and so that's my answer. All right, and still, we'll leave that denominator in the factored form. And if we can factor the numerator, we would factor it. And then, if we can cancel out anything, we cancel it out to simplify it. If we can't, we just leave the numerator and denominator both in the factored form. Again, if that's possible to do, right? Which in this case, it was not. All right, so that's an example of adding a couple of fractions where the denominators do not have any factors in common. So you just have to multiply the numerator and denominator of each fraction by the denominator of the opposite fraction. All right, so to do that, that creates your common denominator. Add the numerator stuff together, distribute, multiply stuff out, combine the like terms, and then try to factor it if you can, see if you can simplify it any further. All right, I'm going to pause the recording here and erase these couple examples, and then I'm going to put up another one that involves subtraction and also involves one where I think the numerator or the denominators will have something in common, so it'll be a little bit trickier to figure out what that common denominator is going to be. All right, so I threw up an example here where we have subtracting two rational expressions. I have 1 over x squared minus 1 minus 2 over x plus 1 squared. Right? And you can tell pretty easily here that these two do not have a common denominator. I mean, their denominators have some of the same elements. They have an x, they have a 1, they have a second power, but they're not exactly the same, right? Those are two completely different expressions. And so what I need to do then is find a common denominator before I can subtract these two fractions. right? Remember, anytime you add or subtract a fraction, it doesn't matter what form that fraction takes, whether it's just numbers or whether there's variables and stuff involved, you cannot add or subtract them unless they have a common denominator. It's one of the key rules of working with fractions. All right, so in order to find the common denominator here, I'm going to factor my denominators if I can, and I can. All right, so that 1 over x squared minus 1, well, hopefully you recognize that the x squared minus 1 is a difference of squares, which factors into an x plus 1, x minus 1. Right, the square root of x squared is x, so I put that in the first place. The square root of 1 is 1, so I put that in the second place of each factor, and then one gets a plus and one of them gets a minus. Right, so that's how that that x squared minus 1 factors, and then minus 2. Now this x plus 1 squared is already in the factored form, right, because it already has that factor of x plus 1, but there's 2 of those factors. So just to make it clear what we have there, I'm just going to write that as x plus 1 times x plus 1. Right, that's what x plus 1 squared means, is I have 2 of those factors of x plus 1 multiplied together. Right, so I have an x plus 1 times an x plus 1. Right, I write it like that because I think it makes it a little bit more clear but as far as what our common denominator here is going to be. Right, so to get our common denominator, I need to include all of the factors that I have in my denominators. All right, and if I have a common factor, like you'll probably notice already that over here I have an x plus 1 factor. Right, I also have an x plus 1 factor over here, but in this case, I actually have 2 of those x plus 1 factors. Right, so if you have a factor that shows up in both of your denominators, but one of them shows up multiple times, your common denominator has to include that factor the most or the maximum number of times it's there. Right, what I mean is, so I have an x plus 1 and an x plus 1. My common denominator is not just going to include one factor of x plus 1, it's going to have to include 2 factors of x plus 1, because this denominator here has 2 of those factors. Right, so in order to get a common denominator, it's going to have 2 factors of the x plus 1 in order to match up with this fraction that's over here. All right, so my common denominator then, if I just kind of write it over here, my common denominator is going to have 2 of those x plus 1 factors, but it's also going to have this x minus 1 factor that I have over here in this first fraction. All right, so that's my common denominator. It's going to be x plus 1, x plus 1, x minus 1. Right, again, I don't have to include the x plus 1 3 times. It's almost like the x plus 1 that I have over here kind of gets swallowed up by this double x plus 1 that I have on this side. So I take that double x plus 1, and then I take the x minus 1 that comes from this first fraction. All right, remember, our common denominator has to include all of the factors that we have in our denominator. So we have the 2 factors of x plus 1 plus the factor of, or times the factor of x minus 1. All right, so once I figure out that that's my common denominator, I have to now create that common denominator in my fraction, or in both of my fractions. Right, so this first fraction has 1 factor of x plus 1, it has the factor of x minus 1, it's missing that second factor of x plus 1. So I have to multiply the top and bottom by x plus 1 over x plus 1. Right, and then minus 2 over x plus 1, x plus 1. The second fraction is missing the factor of x minus 1 from that common denominator, so I have to multiply the top and bottom of that second fraction by the x minus 1. Right, and once I figure that out, now it's a lot like the example we did a few minutes ago with the addition. Right, so now I want to distribute this 1, which is going to give me just an x plus 1, over, and then I'm going to write this as x plus 1 squared times x minus 1. Now that I've got my common denominator, I want to write it as concisely as possible. So I'm going to take those 2 x plus 1s and just write it once with that second power. And then I'm going to take this negative 2 here and distribute it into that parentheses. So it's going to be minus 2x plus 2. Right? Remember, since we're subtracting here, that negative goes with that 2, so I have to distribute that negative with the 2 into that second parentheses to make sure that that negative gets applied to everything. And then if I just combine the like terms in my numerator, I have x minus 2x, which is going to be negative x. I have a plus 1 plus 2, so it's going to be plus 3, over x plus 1 squared times x minus 1. And the factor that I have in my numerator, my negative x plus 3, will not cancel any of those factors in my denominator. And so that is my final result there. right? So that's subtracting rational expressions, finding that common denominator.